Okay, welcome to electrical engineering course, right? 529292, right? And for the polymer, right? Polymer and petrochemical and polymer engineering. Okay. Okay, so this term I will respond for this course. My name is Kirati, right? You can call me Ajahn Kirati. You can call me Ajahn. Teacher is also fine. And another part will handled by Dr. Sudarat. Right? After midterm, you will see Dr. Sudarat. Right? Okay, and you can contact me by the Facebook group. You can see me in the Facebook, right? So if you have some special message, you can send the message to me, right? Or you can send an email, or you can come to C1 building, right? So Dr. Sudarat also at C1 building. And the TA who in charge for this course is PR, TA, PR, okay? And also, she also in the group. Here. PR is also here, right? Tanjalak, right? You can contact her, okay, also. She will take responsibility for maybe for homework also, for your homework, right? Okay. Okay, for this course, the topic that we are going to talk in during this term, right, includes general principle of electrical engineering. So I will talk about the principle of electrical engineering. So and then you will learn DC and AC circuit. I think you know about what is DC, direct current and alternating current. You learn some in physics, right? For DC and AC circuit, this is maybe just remind your knowledge. Yeah. But we go a bit deeper for circuit analysis. The circuit may be more complex, right? It's a more complex circuit for you. And some method to solve DC and AC circuit, right? And then I will talk about magnetic circuit and transformer. Okay, magnetic circuit and transformer, which is maybe more special. And electrical machine, right? Machine like a generator, motor, right? How it works, how the motor works in practice. Unlike in physics, you learn some some wire with the current flow to the wire. This can move, right, inside the magnetic field, right? But in this course, I will talk about the practical motor, how it works. Right? Okay. And then after that, Dr. Sudarat will teach you about the electronic device and circuit, logic gate, digital IC, and control system. Right. So this part will be after midterm, right? After midterm. And the learning outcome of this class is the student obtain the comprehensive learning and some analytical approach to DC and AC circuit, electric machine, electronic device, logic gate, and control system. Okay, logic gate is the digital signal, digital processing signal for logic gate. Okay. I will handle until electrical machine. Okay, so midterm will be here. This is, we come to midterm. Okay, this is midterm. And this is will be your final exam. Okay. So for the content, part 1 will be general principle and of electrical engineering, DC and AC circuit, magnetic circuit and transformer, electrical machine. Okay, yeah. I will try to go slowly, right, as slow as possible. Maybe you come sleepy, I don't know. Maybe you want faster, you can tell me. Okay. And second part is electronic device. You will learn about the diode, transistor, electronic circuit, and the logic gate, digital IC circuit, and digital and control system, right? Which is the basic knowledge in the factory, right? In the building, in the smart building, in the smart factory. It will be useful for you. Okay. So for the grading system of this course, we divide into 2 parts, right? We have homework, quiz, and assignment, maybe for 20%. And the midterm exam is 40%, and final exam 40%. Alright. So more specifically, maybe midterm until the middle of this term. Midterm will be exam for 40, and then homework and assignment 10, right? So I have 50% here. And final also for Dr. Sudarat will have exam for 40 and homework for 10%. So 50-50. Okay? I and Dr. Sudarat will have 50-50 for this class. Okay? And sometimes if I have a lot of quiz, if we have a lot of quiz, the exam may be 30, right? And we have quiz for 10 and homework for 10, for example. Right? It's better, and we found that it's better for you, right? To reduce the score of examination, and we increase the score of homework and quiz and assignment. Okay. Right. So then, if I have quiz, homework, or assignment, please do not absent. So please submit all the work. It will help you, right? At least you just would like to pass this course, right? It's not your main career, but it's maybe helpful for you in the future, right? For this knowledge, okay? And this is the textbook, and also I also put in the drive for you already, right? Okay, and this is some example on the content of these books. Okay, but I'm not use all every chapter, but just maybe some part. I will pick up some part. You don't need to learn the whole book, right? It's very thick book. It's too much. Okay, just some important basic part, right? Okay, maybe chapter 2, fundamental electric circuit, resistive network. Okay, AC network is there. I'm not sure transient and frequency response. Maybe I skip that part. AC power, and then after midterm, it will be part 2. Okay, part 2 will be semiconductor device, right? Transistor, like that. Okay. Also, electric machine is here, right? Electrical machine is here, right? But it's in, I will handle for this part. It will be before midterm for electric machine. So you can go through this textbook, right? You can go ahead. You can do the practice, right? Okay. At the end of each chapter, there is the exercise for you, right? To make a practice, and I will pick up that exercise for your homework, right? To make you do exercise, right? Okay, I think we just start some brief history of the electric, right? So first, the human know about the electric on early 16th century, right, by William Gilbert, right? And he found some sign that we call the charge, right? And that time, people call it electricus on 16th century, right? Okay. And after that, people can invent the device called battery, right, on the 18th century, right? And that can produce the voltage, and we call this the voltaic pi here. Okay. And just a few decades later, Michael Faraday discovered the electromagnetic induction. Right? So we found the relation between electric and magnetic, right? It can induce each other, right? The electric can produce magnetic, the magnetic can produce electric. So we can produce the electricity by this knowledge, right? And then after that, the Maxwell, right, described the theory of electromagnetism, right, by Maxwell. Right? We know better about the relation between electricity and magnetic circuit. Also, this class we will learn about the magnetic circuit also, right? This is a good knowledge to understand the phenomenon about the machine, electric machine, right? Generator and motor, okay. And some equipment in the industrial. Okay, then on 1878, we start using electricity as a commercial, right? And at that time, the inventor, his name is Edison. I think everybody heard his name, right? Edison invented the lamp, and he started working on the system of electrical illumination, right? He tried to provide lighting to the city, right? And he began by tackling the problem of creating the long-lasting incandescent lamp. So what if he found is that he can, at that time people know that if you let the current flow to the filament, the small wire, it will burn and it will create the light, right? But Edison just remove the air from this lamp and make the lamp can stand for a long time, right? Long-lasting incandescent lamp. And then he start provide lighting for the city. At that time, he developed the electricity utility or the company. We start use electricity as a products, right? As a commercial. Okay. And I think next maybe just about next 10 years, right? The scientist named Westinghouse developed the transformer. The transformer is the equipment that can change the level of voltage. We can change the level of voltage for the alternating current, right? For AC current. For AC current, if we use the transformer, it will induce the magnetic field, and we can change the voltage of the electricity very easy by the transformer, right? As we know, I think you know what is transformer, right? So with this convenience, human become used AC electricity rather than DC electricity, right? What Edison developed is on DC system, right? This is DC system. But DC system is difficult to control the voltage. We cannot change the voltage easily. If you have 12 volt DC, it's very difficult to change the voltage, right? But if you have 12 volt AC, you can use transformer, right? Just small transformer to change that voltage, right? So Westinghouse start using AC system, right? Then people transfer from DC to AC at that moment, right? Okay. After that, people start using electricity in the other way, not only for power. So in electrical engineering, we have many fields of study. At the beginning, we used electricity on power. Use this power, right, to drive the motor, to get the light, okay, to get the heat from electricity, right, from the heater, from the air condition. Right, this we use the power of electricity, okay. And later we also use the electricity as the signal, right, as a signal for control system, for communication. This is known as electronic device. So later we start using electricity firstly for radio signal, right? Radio signal by Henry Hertz, who firstly transmit and receive radio signal. Then we also have the programmable computer. Start using digital signal as a programmable computer, and we also have, later on we have transistor, which is one very important electronic device, and you also learn about transistor after midterm, okay? And then we start develop the integrated circuit, or IC, known as IC. Okay. That includes many transistors inside one device, okay? Integrated circuit, okay? And now the processor become a very powerful processor known as microprocessor, right? Yeah. Okay. And then toward this, I think we go to quantum processing, right? Quantum computer. For the next, I think for the next decade, we start using quantum computer. Okay. Okay. Now we come to about this point. So where is the field now, right? The field of study in electrical engineering. And we have electrical power engineer, right? So usually we use the power to create or generate power generation, power transmission, storage and distribution and consumption to use the electricity in the power form, right? In energy form. Or control engineer. We use the signal of electricity, right? To control, right? Design dynamic system, controller of the system. Electronic engineer or microelectronic engineer. Design and develop the integrated circuit and microprocessor, for example. Signal processing, analyze the signal. Okay. Also telecommunication engineer. Okay. And design and transmit the system. The voice, transmit data. Okay. Or transmit any information, right? Image, for example. And computer engineer, design and develop the computer system. And instrumentation, design of sensor, data acquisition equipment, right? And sensor. This is an example of using electricity, right? Okay, for study about the electricity, first we need to know about the basic concept or basic parameter. Know that electricity, what is charge, what is current, what is voltage. what is power and what is energy, right? Okay, the physical phenomena arising from the existence and interaction of electric charge. We know that electricity, right? The charge is moving in the material. It creates the current, right? That we call electricity. Okay. We can observe, experience, and use charge. And this is you learn in physics course, right? We have the charge of electron and proton, right? It is the amount of Coulomb, right? Okay. I think I can go a bit, skip some slide, right? Because this is, I think it's in physics, right? You can go by yourself also. And the charge also have the force to each other, right? The negative charge, we push each other together, right? And the different charge will pull each other, force together, right? So the same charge, right, will repel each other, but the opposite charge will attract one another. And the force in between two charge and two equipment, you have the charge Q1 and Q2, can be computed by this equation, right? This is known as Newton's law, right? Here. Have you ever seen this? Okay. We are not using this equation in this class, okay? We use the different equation, different computation. This is just in introduction. Okay. And the electric current, known as the movement of the charge, right? If the charge moves, the current is there, right? We can observe the movement of charge, and we call that phenomenon as current, right? The current flow here. So the current flow is the change of charge during the time, right? Or the unit will be in Coulomb per second. And this unit we call ampere, right? Ampere is 1 ampere is 1 Coulomb move in 1 second, right? Change in 1 second, change past that point, right? Okay. And for the electric circuit, usually the charge flow, we need to have the closed part, right? For electricity, for electricity we need a closed part for current flow. Otherwise, it cannot flow, right? The open circuit cannot make the current flow. It need to go somewhere, right? Okay. And electric circuit is an interconnection of electrical element, right? What is electrical element? What is electrical element? We have so many types of elements. Some types are the source, some types consume the power, some types dissipate the power, some types store the power, right? So many elements linked together in a closest part we call electric circuit. So firstly, we learn about how to solve the circuit, how to solve the basic circuit, right? Okay. This is the sample circuit, right? Simple circuit. We have battery at the source, right? And we have resistor as a passive element. Okay. Okay. And circuit diagram are the standard for electrical engineer. Okay. So we have so many types of elements. For example, sometimes we can categorize the element into active and passive, maybe active and passive. Okay. Active means source circuit, right? Like battery, active element, or maybe generator, right? passive is, for example, the device that consume power, cannot generate power by itself, right? It cannot generate power by itself. For example, resistor, right? Inductor, capacitor. Or sometimes we call inductor, capacitor as the storage device. So if we talk about battery, maybe it's one kind of storage device, maybe storage device. Okay. But usually in electric analysis, we consider battery as a source, right? It could be a source, it can be consumed the power also. It can store the energy. Okay. But in electric circuit, inductor and capacitor we know as storage device. Storage device. And storage will respond only when there is the change in circuit phenomenon. If nothing change, the storage device will act as will not respond to the circuit. Okay, will not respond to the circuit. We talk about the these two devices later. Okay. Okay. If I say I1 flow from A to B, from node A to node B, right? The connecting point of the circuit we call node, right? We have node is connecting point. If I say the current I1 flow from A to B, I2 flow from B to A, right? In this direction. The direction in corresponding to the arrow, right, is positive. The direction in corresponding to the arrow is positive. And the opposite direction will be negative. Okay, value. So we treat the current flow as a vector, right? Like a vector. Okay. So I1 is, in this case, I1 equal to minus I2, right? Yeah. I1 will equal to minus I2. Okay. Or I1 is the rate of change, rate of flow of change from node A to B. I2 is the rate of flow of change from node B to A, right? I is a current, right? This is the direct current, and we have direct current, right? It's constant, and also if it is an alternating current, it will be analyzed by the sinusoid waveform. Sinusoid waveform is we will have the sine or cosine shape, right? It's a sinusoidal waveform. We call this type of waveform as sinusoidal waveform. And we can analyze by using sine or cosine function, right? Yeah. For alternating current. Okay, again you have some basic knowledge about what I talk, right? Okay, for voltage. Voltage is the driving force of the electrical current between 2 points. If there is the voltage, is the current will be there in the closed circuit, right? The voltage will drive the current, right, flow from positive terminal to negative terminal, right? In this case, if I say VAB is mean the positive in the in node A, and negative is on node B, right? So VAB is voltage at terminal A with respect to terminal B, and VBA is in the opposite side, right? B respect to A. So similarly, VAB will equal to minus VBA, right? Here. Okay. And then in any circuit, when we analyze the circuit, usually we have one reference node, right? And sometimes we call ground node. Right? In the circuit voltage, often defined relative to ground. Okay. Okay, the voltage unit is in joule per coulomb, right? Joule per coulomb is energy to drive the charge, the force to drive the charge, right? Joule per coulomb, or we call volt as its unit, right? Okay. This is also in physics, right? But we are not using this equation in this class. Okay. Power also, right? And the power of current and voltage, we can compute it by the current multiplied with voltage, right? The power. Yeah. P is I multiplied with V. I think you're familiar with this power also, right? Yeah. And the unit is watt. Joule per second, or the unit is in watt, right? Okay. And what is 1 joule of energy converted to in 1 second, right? Energy dispatch 1 joule in 1 second. This we call watt. Okay. Okay, we talk about that watt, V, volt, and amp, and watt, and so on, right? And in AC system, we have another power called reactive power. Active power, reactive power, apparent power. Okay. You learn at the end of this part 1. Okay. And this is an example of circuit schematic diagram, right? So the above figure is the actual device, right? But when electrical engineer compute about this circuit, we will draw it in the circuit diagram, right? Using the symbol at below symbol, right? So in this device, we have battery, right? And we have switch here, right? And also we have a lamp bulb here, right? If we close switch, the lamp will be turned on, right? So we will use this type of symbol when we analyze the circuit. Okay, this is the element, some basic important element here, right? This is the, if you saw this type of symbol, it means this is diode, right? Capacitor, inductor, resistor, voltage source, DC, and AC voltage source, for example. And this part is the logic circuit, right? Digital logic circuit. Have you ever seen this type in any course? No. Okay. Never. Okay. This is for digital signal, digital circuit. I think this is maybe okay, right? Okay. Maybe this is source and resistor. You have learned something about this. Okay. And this is the actual resistor, right? Resistor. And in the circuit, we will use this symbol. This symbol for resistor. And the resistance is the physical property of an element that impede the flow of current. The unit of resistance are in ohm, right? Okay. The resistivity, we call rho, is the ability of material to resist current flow. The unit of resistivity are ohm meter. Okay, this is each element will have different resistivity, right, to the current. And total uh, resistivity of the whole material we call resistance. Okay, and this is the inside of the resistor, right? For the resistor, we have color band. The color band will provide information about the resistance of this element. Okay, so I think in the laboratory you will use, right? In physics you have laboratory. Okay, you have ever read the color code, right? Color code of the resistor. Okay, it's fine. Okay, you do it again in electrical laboratory, right? Next term, right? This term also you do the laboratory this term. Okay, I thought that after theory class you go to laboratory class next term. No, in the same term. Okay, this is the color code, right? So I think this part you will learn in the laboratory class. Okay, laboratory section. Okay, yeah, this is the information for the color band. Okay, I think it's okay. And we have Ohm laws, right? Ohm law is the relation between voltage and current, right? When we have, for example, we have the battery and we supply the battery into one resistor, one element, any element, and then the voltage. This is the voltage and this is the current. What Ohm found is that when he changed the voltage, the current is changed. Okay, one element for the resistive element, when he changed the voltage, if you provide one voltage to this element, we get one current. If you change the voltage, the current is changed. Okay, proportionally to the voltage, right? And the slope we call resistance, right? R, right? V is I into R, right? But in this case, I is here, V is here. The slope will be called the resistance of the equipment, right? V equal to R into I. Also, we have another device known as capacitor. This is the symbol of capacitor, and this is the actual capacitor. And the capacitor will actually not work for DC circuit. When the circuits have some change or transient state, the capacitor will respond to the circuit. Otherwise, it becomes open circuit. Right? In DC system, the capacitor becomes open circuit. Yeah. Okay. And this is the capacitor, right? In the laboratory or in the electronic device. Okay. And the capacitor consists of a pair of conductors separated by a dielectric here, right? Dielectric material or the insulator, and this structure will provide the capacitance of between two sides of the capacitor here, right? Okay, and we can have the capacitance by this equation. Epsilon is the permittivity of the material, inner material, right? A is the area and D is the distance. Okay, and the capacitance. Okay, and the property of capacitance is the ability of material to store charge. So capacitor is the storage device. If you put the voltage into this element, right, we have the capacitor, right? if we switch the voltage, right? Firstly, is we don't have, it's not have the full volt, right? T here, this is full from 0, right? And it will, the voltage will increase into some value if you switch the voltage for a long time. For example, 12 volt. For a long time, the voltage across the capacitor become 12 volt, right? Like this. And then the voltage across the capacitor become 12 volt. It means that it acts as the open circuit, right? Just become open circuit, right? Because across this path is 12 volt, similar to the source here. No current flow anymore, right? No current flow anymore. If you draw the graph for the current, when we first switch the current to the capacitor, there is some current here, right? After a long time, the current becomes 0. No current flow because it becomes open circuit. Like we open the switch, right? Here we open this switch for the capacitor. Okay. So it's not changed. If nothing changed, if we not switch any switching in the circuit, it's become open circuit for capacitor. But it store the energy already. It store the volt for 12 volt here for capacitor. Okay. So we learn about how to compute the capacitor phenomena. Okay. The unit of capacitance is in farad. Okay. In farad or F. Here is the unit of capacitance. Okay, this is what I have talked. The capacitor plate attached to negative terminal accept electron from battery. The capacitor plate attached to positive terminal accept proton from the battery. If we connect this circuit, right, the battery will charge the capacitor until it's full storage, and the voltage is just the same as battery, right? Okay. If you connect one bulb here, you will see the bulb will light on until the capacitor get full charge. After capacitor get full charge, there is no electric cause the lamp will turn off. Okay, you can do this experiment. Okay. Okay. After that, if you replace the battery by a piece of wire, right? You make a short circuit here. The capacitor will discharge to the lamp. Okay, it will discharge to the lamp, and the lamp will turn on, right? Until it's discharged or charged. Okay, the lamp will be off. It is a property of capacitor. Okay, it acts like a battery, right? Just like a battery, but it charges faster and discharges faster. Okay, it charges very fast and it discharges very fast. It's faster than battery, right? Okay, the battery will make slow charge and slow discharge. So nowadays we have one technology called supercapacitor. Supercap. Have you ever heard this word? Supercapacitor we install in the electric vehicle, right, to produce for fast charge. Okay, we use supercapacitor instead of battery, right, in many equipment in future. Okay, the energy stored in the capacitor can be computed by this equation, right? Okay, it's 1/2 CV square. This is the energy storage. So capacitor is one of the energy storage device. Okay, this store and discharge, charge, discharge and discharge for capacitor. Okay. Next device is inductor. Inductor is a coil. We can make inductor by ourselves, right? By turn into the coil, right? Turn the wire into the coil, right? So an inductor is a two-terminal element consists of wire with n turn, right? Capable of storing energy in the form of magnetic field. Inductor also one of storage device, but it store the energy in terms of magnetic field. Capacitor store in the charge, right? In the charge form, but inductor store in the magnetic field. Okay. The inductance, we use the symbol L, right? This is symbol of inductance. Right? Inductance is a measure of ability of device to store energy in form of magnetic field. It's measured in Henry. Right? The unit is in Henry. Here. Okay. And this is the inductance. Okay. The inductance property of the element can be computed by this formula. Right? Mu is the permeability of the free space, K is the constant coefficient, right? N is number of turns, A is area, and L is the range of the coil, right? Okay. Again, we are not using this equation in this class, okay? And the magnetic field of the inductor can generate and induce voltage. It can be used to drive the current. V is L di by dt, right? If you move the magnetic field, you get the current flow, right? Here. Okay. While building the magnetic field, the inductor resists the current flow here. So if you move some magnetic field into the coils, you produce the current. Okay. Here. Okay, this is the relation between current and voltage. The current needs to be changed, then the voltage exists. Okay. If the current is not changed, for constant current, no voltage is there. Okay. Okay. Okay, let's see this circuit. Right? What happened to the light bulb when the switch is closed here? When the switch is closed, the current flow here, right? What happened to the light bulb when the switch is open? Okay. First, if we close this switch, the current will flow to the lamp. Okay, the lamp will be on, right? And also the current will flow from this part also. We have dV by dt. And after a long time, the inductor, if the voltage is not changed, this part becomes short circuit. The current will be turned off, right? This is when we firstly close, it will be on, and then it will be off. Okay. When we turn off the switch again, it will be on again, and then it will be off later. Yeah. Okay. Next, the energy stored in the inductor, right? We can compute it by 1/2 Li squared. Okay. Similar to the capacitance. So the inductor also the storage device also. Okay. Okay. Okay, I think I go for this the first slide for today. Okay. Maybe. Usually you need to have some break after 1 hour break. No. Oh, it's good to have a break. Okay. But okay, just this time I think. Maybe it's better to have some break, right? Okay, Make a break for 5 minutes. Okay.